Look at this floor plan. Finding the distance straight across the room is simple. Just count grid units. But to find the exact diagonal distance between the bed and bathroom door, simple counting won't work. We need a mathematical framework. To calculate the diagonal, we strip away the walls and map the space onto a Cartesian plane, organized around an x-axis and y-axis. Measuring a horizontal line is straightforward arithmetic. Find the difference between coordinates. 7 minus 3 equals 4. But when the path cuts diagonally across the grid, subtraction alone fails. Finding this exact length requires the geometry of right-angled triangles. Let's examine a diagonal path in the first quadrant, connecting point A at 3, 4 down to point D at 7, 1. To find the length of this diagonal, we build a right triangle around it. We trace a horizontal path straight over from D and a vertical drop straight down from A. They meet at a new corner, point C, at 3, 1. Now we have flat lines we can easily measure. The horizontal base is just the difference in the x-coordinates. 7 minus 3 equals 4. The vertical height is the difference in the y-coordinates. 4 minus 1 equals 3. With our two legs measured at 4 and 3, we apply the Bauer-Pythagorean theorem. 4 squared plus 3 squared equals 16 plus 9, yielding 25. Take the square root, and our diagonal length is exactly 5. Every diagonal distance in this positive quadrant is just the hypotenuse of a hidden right triangle, built directly from the differences in its coordinates. When our points cross the y-axis into negative space, the geometric process remains exactly the same. However, the arithmetic requires strict attention. You have to handle the negative signs correctly. Let's test this. Pause the video and calculate the exact length of the new horizontal leg using these negative x coordinates. We subtract -7 from -3. That double negative becomes addition, meaning -3 plus 7 equals 4. Physical distance is an absolute length. The base is 4 units long, and the vertical leg remains 3 units long. Run the theorem again, and the diagonal is still exactly 5 units. The rules of calculating distance hold up perfectly in negative space, provided you correctly subtract the negative integers. Let's build a universal rule. We place two abstract points on the grid, P1 and P2. The horizontal leg of their hidden triangle is the difference in x values. The vertical leg is the difference in y values. Plugging these into the Pythagorean theorem produces the final distance formula. To execute this easily, memorize this sequence. Subtract the x's, subtract the y's, square them, add them, and take the root. And here is a final helpful shortcut. Because squaring any number forces it to become positive, the order in which you subtract the coordinates doesn't actually matter, as long as you are consistent. By laying a Cartesian grid over physical space, we turn spatial relationships into solvable algebra, allowing us to pinpoint the exact distance between any 2 points in the plane.